All right, today we're looking at how do we graph quadratic inequalities. So let's just take a moment to think about what were inequalities? Well, the inequalities that we've seen before look a little bit like this. Remember that they could have a dashed or a solid line, and you either shade above or below. Like the inequality here is y is less than 3x minus 1. Well, quadratic inequalities work the same way. The only difference is that now it's a quadratic that gets shaded above or below. You see, this inequality right here is y is less than 3x squared minus 1. All right, so how do we do it? All right, so we're going to do this in 3 steps. The first thing, we're just going to graph the parabola. And see here, we'd make it a dashed parabola if it was less than or greater than. See here, it was less than, so this is a dashed parabola. Next, we would test a point inside the parabola to see if it was a solution. So like usually you can test the point like 0, 0, or anywhere inside the parabola. Then you say, okay, was it a solution? If yes, shade inside. No, shade outside. So was 0, 0 a solution for this parabola? No, because it's not in the shaded region. So yeah, we just shade outside. So let's practice. All right, our first example is y is less than or equal to negative x squared plus 2x plus 3. Now, it's been a while since we've graphed quadratics, so we have to remember, all right, this is in general form. How do I find the vertex? Remember that the vertex, right, can be found by first doing x equals the opposite of b over 2a. So in this case, that would be negative 2 over 2 times negative 1. So negative 2 over negative 2 is 1. That's the x-coordinate of the vertex. To find the y, you plug it back in, right? So negative 1 squared plus 2 times 1 plus 3 is 4. So my vertex is at 1, 4. All right, so I plot that point, 1, 4. What else goes through the vertex? It's this x right here, right? This axis of symmetry. So I'm going to go ahead and plot that too. All right, and since it's in general form, what's really nice here is that this 3, remember, is a y-intercept. So I know I've got this point 3 reflected over the axis of symmetry. All right, and now I've got a pretty clear picture of what this graph's going to look like. I know it opens down just because it was a negative x squared. Just to be sure, since we didn't really use other points, right? Just to be sure that we're going to test a point inside, let's test the point right underneath this vertex. That's the point 1, 3. Oh, and also before I move on, notice that I graphed this as a solid parabola because this was less than or equal to. All right, so to test the point 1, 3, remember that this is just an x and this is a y. So we're just going to plug those in for x and y to see if we get a true statement. 3 is less than or equal to negative 1 squared plus 2 times 1 plus 3. Well, we just saw that if you plug 1 in, you get 4. So is 3 less than or equal to 4? Yes, that's a true statement. So I'm going to shade inside the parabola. All right, let's do another example. Y is less than 2x squared minus 4x plus 1. All right, first of all, we notice that this will be a dashed parabola because it's strictly less than. All right, so let's start by finding our axis of symmetry, which will help us with the vertex. X is equal to the opposite of b over 2a. So that's 4 over 2 times 2. 4 over 4 is, again, 1. So I have an axis of symmetry at x equals 1. Sorry, it's hard to do that on here. I'm going to plug that back in. 2 times 1 squared minus 4 times 1 plus 1. That's 2 minus 4 plus 1 is negative 1. So my vertex here is at negative 1 on the axis of symmetry. Remember that this is our y-intercept. So come up here. And we also remember just from our rules, if the a is stretch of 2, look, instead of going over 1 up 1, I went over 1 up 2. So if I wanted to plot more points, instead of going over 2 up 4, I would go over 2 up 8 because we're multiplying all the y values by 2. So just draw a rough sketch. It's a dashed parabola. Okay, now let's test a point inside. Why don't we test this point right here, 1, 0. It's just above our vertex, just to be safe. So we're going to test 1, 0. And notice, just like last time, whenever we test points that are on the axis, on the axis of symmetry, like 1, right? We already know what this value is going to be. So, like, is 0 less than 2 times 1 squared minus 4 times 1 plus 1? And even though I didn't write it down, we already saw that that's equal to negative 1. So is 0 less than negative 1? No, it's not. So I have to shade outside the parabola. So this whole space outside the parabola would be shaded. All right, to graph systems of quadratic inequalities, you really, just like systems of inequalities, you graph both of them, do the shading, and wherever their shading intersects, that's the solution. So here we have y is greater than x squared minus 2, and y is less than or equal to negative x squared minus 3x plus 4. All the same steps. So we're lucky here in this first one with y is greater than x squared minus 2. This one, since we don't have any x as well, this is just a shift down 2 from the parent function. So we'll just go down 2 to this negative 2, and then we can just graph the parent function over 2 up 4. All right, and this is a dashed parabola. All right, I'm going to hold off on shading that for just a second. Now for the other quadratic in this system, we're going to have to do a little bit more work. Let's see, its axis of symmetry is at x equals the opposite of b, so 3 over 2 times negative 1. So this is at negative 3 over 2, or negative 1.5, just to help us graph a little bit. So at negative 1.5, it's not the nicest thing. And then we'll have to plug that back in to find the vertex. Negative 1.5 squared minus 3 times 1.5 plus 4. This is all equal to 6.25. So that's going to be my vertex. Negative 1.5, 6.25. So just above 6. All right, we also know that this 4 is the y-intercept. So let's just graph here at 4 and then reflect that over, so we'd have a point here at 3, 4. This is a solid graph. All right, now it's time for me to test the points inside of each of these. For that, I'm going to leave it up to you and see what you come up with. Just test the points directly either above this vertex or below this vertex. All right, so you should have seen that it's going to, they're both shaded inside, so this area where it would be inside of both parabolas, if we were to, extend this parabola down a little bit more, this would be our solution region. All right, and that's graphing quadratic inequalities.